the node info window, and the pipe info window display node and pipe information and allow us to edit that information. These windows can be configured. The default setting is for them to stay pinned or docked to the right-hand border of the interface and interchange depending on whether a node or a pipe was last selected. The size and appearance of these windows are controlled from the configuration menu. There are 6 options. This is the default option. This option shows both the node info window and the pipe info window simultaneously. If the windows don't populate, click on a pipe and a node. The next option creates a single window, which is sizable. But when we click OK, we see that the window is missing. Sometimes it will draw behind the program window. To bring it to the front, click on a node or a pipe. Because this window is sizable, it is particularly useful when using group mode to select multiple nodes or pipes. Using the Group Select tool, if we select a group with more nodes or pipes than can be shown in the window simultaneously, a horizontal scroll bar appears at the bottom of the window, which allows us to see more of the group. If you don't see the right-hand arrow on the scroll bar, resize the window until you do. This option shows a single window, which is not sizable. It's used when you wish to see more of the map area. This option turns off both the node and pipe info windows. This last option displays both a node and pipe info window, which are sizable and can be moved. They can even be moved outside of the program window. The pipe info window and the node info window allow us to enter data by clicking on the fields in the right-hand column. For some fields, we just click inside the field and enter the data. But for other fields, clicking brings up additional data entry screens. If you click on the pump ID field for a table pump, the pump curve screen appears where you can input head flow data. Some fields allow a selection to be made. Clicking in the pump type field brings up a drop-down list of available pump types. The pipe type field aggregates 3 different physical characteristics: pipe material, pressure rating, and diameter. The DI we see in the pipe material portion of the pipe type field stands for ductile iron. The pipe material and pressure rating are descriptive only and do not affect the simulation. The pipe diameter is in units of inches or millimeters. Clicking on this field brings up a drop-down list which allows you to change the pipe type. However, you may also change these parameters individually by unclicking the Display Pipe Type as One Item button. By default, this button is active which we can see by the blue background. When we click on this button to inactivate it, we see that the material, diameter, and pressure rating characteristics have been disaggregated and can be edited individually. Let's say we want to enter data for a pipe type that doesn't exist. For example, a 4-inch ductile iron pipe. We can see that this is not in our list of available pipe types. Click on the diameter field and enter the new value. A data entry screen titled Add New Pipe Type will appear. If it doesn't appear, click on the pipe you are editing to bring it up. We see the new pipe type here with a 4-inch diameter. Note that other parameters are automatically populated. For example, a roughness value of 130 appears in the roughness field. This is a default value for ductile iron pipes, which was obtained from the pipe type table under the Components menu. But you may wish to change the value to something other than the default. Here is the Components menu, and this is the pipe type table. Now if we click on the Display Pipe Type as one item button, we see that a 4-inch ductile iron pipe has been added to the list of available pipes. Clicking inside the Fittings field also brings up a data entry screen. Here we can enter the quantity of a number of different fittings, and the program assigns the loss coefficient K for each fitting and sums them. The user can also specify additional K in this field, which is then added to the total K from the default types of fittings. Clicking on the Show User Data button brings up additional fields. You can also add more user-defined fields by clicking the New User Data item button. For nodes, this button brings up a library of node types, which are populated with manufacturer's data. This button displays the XY coordinates of the node, which are in units of feet or meters. This button displays the index number of a node or a pipe, which corresponds to a row number in the data tables. We can find the entry for this pump by clicking on the Edit Data Tables button. This is how we switch between nodes and pipes when viewing the data tables. Here's the row that corresponds to the pump. The Image menu button allows you to load and view images associated with a particular node. Click on the Load Image button, which takes us to KYpipe's Images folder. Select the image you want and click Open. You can use the slider bar to scale the image. This button turns the images off, and this one turns them back on. The Node Data Help button brings up information specific to the type of node. including a description of units. This is usually the first place to look if you have any questions about how to enter or interpret data for a particular type of node. If we click on a pipe and look at the length field, we see that it is colored a paler shade of blue than the other fields in the pipe info window. This tells us that the value entered in this field is unfixed. Because it is unfixed, the pipe length can be changed by moving one of the nodes associated with the pipe. For instance, pipe P14 is 2,550 feet long. If I move one of the nodes associated with this pipe, the length changes. If a length value is entered, then the length becomes fixed. We now see that moving the node does not alter the length of the pipe. Also, we see the color of the length field has changed to indicate its fixed status. To unfix a field, click on the row header and under Edit Type, click the radio button for Unfix Calculate. Then apply the edit. As another example, when roughness is unfixed, it allows the user to simulate pipe aging by specifying cases whose time is set a certain number of years in the future. More information on pipe types and pipe aging is available in another video. When we run an analysis, we can use the Node Info and Pipe Info windows to view the results. Click on the Quick Analysis button. This particular file is a surge file. When the analysis is complete, click on a node and click the Show Graph in Table button. This brings up a thumbnail of the graph, and clicking on the thumbnail shows the graph full size. Clicking on the Table button shows the data used to build the graph. Also, some of the results of the analysis can be seen within the Info window. Click on the Display Result A button. Result A shows the pressure in a node or the flow in a pipe at a time or case set by the user. Time is for surge files and extended period simulations, and case is for steady-state simulations. Like Result A, Result B also shows node pressure and pipe flow, but Result B can be set at a different time or case than Result A, so the user can compare the different outputs. The individual times or cases can be set by clicking in this field. If we click on the Show Min, Max, and Average button, we see the minimum, maximum, and average pressures for that node displayed in the info window. This button allows you to toggle the graph's display to show results for the node's inlet side, results external to the node, or results from the outlet side for node types that have these characteristics. Normally, KYpipe produces output for the inlet and outlet sides of a node. External calculations are only performed for certain surge applications. The info windows can be used in group edit mode. As an example, let's change the diameter of a group of pipes. Click on the Group Select button. This allows us to select multiple pipes simultaneously. Alternately, we could use the Group Box button. Notice that only pipes that fall completely within the box are selected. The third option is the Group Polygon button. To draw the polygon, use left clicks, but complete it with a right click. As with the group box, only pipes that fall totally within the polygon are selected. To edit the diameter of these pipes, click on the row header for pipe type. This brings up a group editing box. But before we make changes, let's look at the right-hand side of the group editing box. Here we see the Group Select menu. This box lists the universe of pipe types we can select. The buttons underneath the list are another way to generate and modify the selected group. For instance, we could add all the 10-inch pipes to our group. If we do this, we can see the new group by looking at the map area and also by using the horizontal scroll bar in the Node Info window. But in this case, we'll just use the group we created first using the Group Polygon tool, so I'll use the Group Editing menu to remove the 10-inch pipes from our group. The left-hand side of the box is where we edit the data associated with our group. The drop-down list shows us the possible choices. We'll choose a 4-inch ductile iron pipe. Now, if we go back to the Pipe Info window, we can use the scroll bar to see that the pipe type has been changed to 4-inch ductile iron for all the selected pipes. As another example, let's say we want to modify our node elevations. The initial elevation values were set at the ground surface elevation, but we're going to change them to account for buried depth. To do this, we can click on the Edit menu button and then click on Select All Nodes. If the info window is blank, double-click on a previously selected node. The reason we double-click is that the first click unselects the node, and the second click reselects it. This populates the info window and adds the node back into our group. Now we can proceed. However, we don't want to modify the elevations of all the nodes, since not all of them are buried. Some of them are on the surface. To select only the nodes we wish to edit, click on the Node Type row header to bring up the Group Edit box. let's remove the hydrants, the pump, the reservoir, and the tank from the selection. Use a control click to highlight these, and then click on Remove from Group. Now the group consists of valves, intermediate nodes, and junction nodes. Another way to select only these node types would be to click on the node type row header, then control-click on intermediate nodes, junctions, and valves. Then click New Group. To edit the buried nodes, click on the elevation row header, and in the Group Edit box, click the radio button for Add, and in the Value field, enter -3. But before we click Apply Edit, let's look at the elevation for the first node, which is 606. Now we'll apply the edit, and we see its elevation changes to 603.